Alright, in this video we're going to pick up the data file after it comes out of words and phrases, and we're going to start applying some dictionaries to it. So part of the attendee materials actually includes a list of word lists that looks something like this. So there's 23 individual text files in this folder, and if you open some of them, you'll see that this is a descriptive list of colors. This one is a list of words that refer to size, shape, and weight. And this one is a list of generic labels for people. So these are all word lists that were developed specifically to go along with these picture tasks, which is why you have some other people lists, such as this one called People Without Projections. This is where the author is just trying to use a general word to refer to the people in the picture, versus People with Projections, where the writer is kind of imposing some sort of relationship or label on the person in the picture. So they're a custodian, or they're a dad, or they're a CEO, etc. So I invite you to explore the lists themselves. Right now we're going to focus on how to apply the lists. You'll also see some very short lists, like first person singular pronouns. You'll find plenty of excellent part of speech taggers within R, but you're not going to get down to the granularity of first person singular. You're really just going to end at the pronoun level. And a lot of research has actually shown that pronouns are particularly interesting. So we gave you the entire exhaustive list of different variations of pronouns. So coming back to the code, we've brought in our list of lists. So here's our 23 lists that we've read in from that folder. And what this loop is going to do is it's going to apply every list in that folder to every author. So for example, if we go with the first person pronouns list, it's going to go through each author and it's going to count how many times that author uses anything on that list. What it's going to do is create a count variable, a binary variable, and a normalized variable. And what you'll wind up with is the list name underscore count, the list name underscore bin for binary, and the list name underscore normalized. So if we give it 23 lists, we're expecting 23 times 3 is 69 different new variables created. So let's go ahead and run this entire loop. All right, that is finished running, and let's take a look at the column names in our data file. And indeed, at the end of our data file now, for every list, we have a count, a binary, and a normalized view of that variable. So this is an excellent way to create all of your new variables in one batch by running through a variety of different lists. Creating the lists themselves can be rather labor intensive, but this is really where the hypothesis driven aspect of the research comes in trying to create intelligent lists that you think are going to relate well to your outcome. At this point, you could continue to apply more and more techniques to create more and more variables. Or you could start analyzing some of the thousands of variables that have been created against your outcome of interest.